Now I am going to talk about how the project is implemented. Multi-layered architecture is used to develop Optime application. Layers are BLL, which means Business Logic Layer, DAL, that stands for Data Access Layer, Core Layer, Entities, Web API, Mobile and Android layers. Entities layer is scene concrete folder contains entities that comes from the database connection. Optime context class is placed in here, which is derived from DB context. It contains table as a property in which type is DB set. I will explain how costs work with a selected entity called node after this slide. Node entity is shown with its properties. It is the view of node table from the database. Every table has its own view in its own class. Node validation is the class that identifies rules of node entity. It is connected to each other with table annotation. Rules are defined over the property, such as required data annotation in the description property. Core layer is defined for general features of the project. iEntity repository interface is defined for the skeleton of the repository class. It is a generic interface. The common operations of entities are defined inside of this interface. EF entity repository base, which is shown in the figure, used to define common operations of entities such as delete, get, update, and add. It is inherited by iEntity repository, which is the skeleton for this class. iEntity is defined for base of entities as shown. Ninjak controller factory is come from Ninjak package, which can be installed using Nugget Package Manager. It is used by controllers. Data access layer is defined in the figure. It contains data operations for entities. iNodeDal interface is shown in the picture, which is the skeleton of EF NodeDal class, and it is derived from iEntity repository. EF NodeDal is created for node entity operations. It is inherited from EF entity repository base because of common operations. Business logic layer is defined in the project. This layer is defined to catch errors before DLL layer. Business model is defined to bind node service and node manager to each other and to bind iNodeDal to EF NodeDal. The class is derived from Ninjak model, which comes from Ninjak package in the figure. iNode service is defined operations of node entity as seen in the image. There are some basic operations shown. Node manager is inherited from iNode service to fill inside of the methods, which implemented from iNode service interface. Web API layer was created to connect mobile device with database operations. Node controllers class is used to connect node methods between mobile and BLL. It is derived from API controller as shown. The remaining costs for node controller are shown here. In the mobile layer, mobile design is located. There are folders such as custom controls that contain some items belong to user interface. Helpers models, which includes some helper classes. Models that will be used for getting data from Web API. Android layer is located for platform-specific operations. There are some folders as custom renderers that corresponds to custom controls in the mobile layer. Custom editor is identified for add new properties to editor item in the Android. Custom editor is inherited from editor class in the mobile layer. Custom editor renderer is defined in the Android layer for platform-specific operations. This class is created to get transparent background in the editor. Node View model is defined to get data from Web API. It is used to create MVVM approach. Project List Page class is defined to get data from Web API using Node View model. Some controls can be controlled in the class, which are defined in the XAML page. XAML page is the design part for the code. Projects page XAML code located in the figure. With binding operation, whole data come from class to XAML page. Scheduler algorithm of the project is defined in the figure. In this section, some important properties were identified. To use scheduler algorithm, user is the most important because this algorithm generates a plan depend on user. Then tasks were got depend on user. In this figure, available time of the user is calculated to schedule task depend on time in the algorithm. Situations are calculated in here, such as user can sleep in after midnight or before midnight. Available tasks are calculated, which is got by the status of tasks. Depending on status tasks, subtasks are got. Schedule is created here with the last part of the algorithm. Schedule Manager class is generated to specific operations of schedule algorithm to get in different layers, such as web services, send or get data from mobile layer and database layer. Schedule controller in the slide is created to build services to reach schedule algorithm objects from mobile devices.